Hello everyone, welcome to the fourth video lecture on circuit analysis. In the last third video lecture, we have seen what does it mean electric power, electric energy, the types of circuit elements, just like the passive circuit elements and the active circuit elements. Okay, under the active circuit elements, we have seen the two very important sources, which is voltage source and current sources, and we have seen also the types of sources, the independent sources and the dependent sources, and how they are represented in the circuit using their symbol. And also we have seen the two types of dependent sources. That means we have two types of dependent voltage source and two types of dependent current source, and how they are represented in the circuit. Okay, so today let's see some examples which will be elaborate how power will be calculated or be calculated. Okay, now let's calculate this. It says that calculate the power absorbed or supplied by each element in the circuit shown below. Okay, so as you can see, all the quantities are given in the circuit as the circuit shows. Okay, we have two types of sources, one independent voltage source and the other one is dependent current source. Okay, so you can consider this is this is the independent voltage source. Okay, source, and this one is the dependent current source. As you can see, the circuit has a total of 4 elements. This is the first element, and this one is the second element, and this one is the third element, and this one is the fourth element in the circuit. So the others are the connecting wires. So we have seen that the passive power sign convention, So by considering the direction of the current flow, so we can determine the values of the power, Okay, the values of the power. So for the first one, let's consider P1. Okay, that means for P1, you can see here the 5 ampere current source is leaving the positive terminal of the 20 volt voltage source, and it's entering the negative terminal of the 20 voltage source. Okay, so for this case, using passive sign convention, power will be negative. To mean that power should be supplied by using the source. So you know, power is voltage times current. So for P1, the voltage is 20 volt times the current is 5 ampere. So it should be negative 100 watt. Okay, because to mean that power is supplied. When it comes to P2, okay, P2, as you can see here, the 5 ampere current is flowing into the positive terminal of P2 and leaving the negative terminal. So for this case, power is absorbed. So it should be positive. Okay, so still V, which is given by voltage current. Okay, so the voltage is 12 volt times current is 5 ampere, so it should be 60 watt, and it is positive. It's positive using the passive sign convention. When it comes to P3, again, the current is entering the positive terminal and leaving the the negative terminal. So the P3 should be given by voltage times current. So for this terminal, the voltage is 8 volt, 8 volt times the current is 6 ampere, so this should be 48 watt, 48 watt, okay, 48 watt. The force power, the force P4 is given by voltage times current, but it is negative because the direction of the current is leaving the positive terminal and entering the negative terminal, but current I can come here. The current I is 0.2 times I, because it is a dependent current source. So the current which is passing through element 2 will control the dependent current source. Okay, so which is 0.2 times 5, so it should be 1 ampere. So P4 should be negative 8 times 1, which is negative 8 watt. Okay, because why it's negative, why it is the voltage across the dependent current source is 8 volt, because as you can see here, this terminal, okay, and this terminal, they are connected in parallel. So the 8 volt voltage across the P3 is equivalent to the voltage across P4, okay? So we have this. So under the conservation of energy, we know that the total power supplied by the source, which is equal to the total power absorbed by the other elements, okay? So the total power supplied, which is equals to P1 plus P4, okay, which is minus 100, okay, so minus 8 watt, which is equals to minus 100, 8 watt, okay, minus 100. Total power absorbed, okay, total power absorbed, which is equals to P2 plus P3. So the P2 it is 60 watt plus P3 it is 48 watt. So totally, which is 108 watt. Okay, 108 watt. So as you can see here, the total power supplied, which is equals to the total power absorbed. That means P1 plus P4, which is equals to P2 plus P3, which is 108 is equals to 108. Okay, so that's how we can determine the power absorbed by elements. The second one, you can see here, for the same circuit, we are asked to determine the power absorbed or supplied by each element in the circuit. Okay, so with the same procedure as what we have seen in the previous slide. So we have 4 elements still in the circuit, one dependent voltage source, and the other one is independent voltage source. So totally we have 2 types of sources, one independent voltage source and one dependent voltage source. Okay, so when you come to P1, for P1, okay, you can consider this point using the current which is flowing in P3 and P4. Okay, P4. Okay, so P1 it is given by 5 volt. It is positive. Okay, P1 it is 5 volt times the current on this direction is 3 plus 5 ampere, which is 8 8 ampere. Okay, so 5 times 8 it is 40 watt. It is 40 watt, and it is positive because the current is leaving the positive, so it should be negative. Sorry, it should be negative. Okay, so for under the 2-volt voltage source, the current is entering the positive terminal and leaving the negative terminal. So P2 should be it is positive. That means 2 volt times the current is 8. Okay, so it should be 60 watt. 60 watt. And again, P3 is still it is the current is entering the positive terminal and leaving the negative terminal. So P3 should be positive, and as given by the current 3 ampere, okay, times 0.6 times 5 ampere. Okay, the voltage is 0.6 I. Okay, the voltage is 0.6 I times 3 ampere, and we have given that I, it is 5 ampere. Okay, so it should be 0.6 times 5 times 3. Okay, so it is 3 times 3. Okay, this one is 3. This one is 3. So which is 9 watt. It's 9 watt. And finally, let's consider P4. Which is 3 volt times 5 ampere. Okay, 5 ampere. So it is 15 watt. Okay, 15 watt. So the total power supplied by the circuit is total power supplied by the circuit. Power supplied by circuit is P1. Okay, and total power absorbed by the other elements. Total power, okay, absorbed by the other element is which is P2 plus P3 plus P4. Okay, so this is minus 40, and this is which is 40. So as you can see, the total power supplied by the circuit, which is equals to minus 40, and the total power absorbed by, which is P2 plus P3 plus P4, which is 40 watt. Okay, 40 watt. So from this, we can conclude that P1 is equals to P2 plus P3 plus P4. Okay, that means the total power absorbed by the circuit, supplied by the circuit, which is equals to the total power absorbed by the other circuit elements. Okay, when come to the other example, obtain the voltage V in the branch shown below for I2 is equals to 1 ampere. Okay, 1 ampere. So you can see here the voltage is across this terminal. This is across this terminal. Okay, this is the voltage. We are asked to determine the voltage across this terminal. Okay, this terminal. So this voltage is given, it is V. Okay, so the voltage on this terminal, okay, the voltage on this terminal is equals to the voltage on this terminal plus the voltage on this terminal. So we can write V, which is equals to Vx plus 10 volt. What's Vx? Vx, which is equals to 50 I2. What's I2? That is 1 ampere. So Vx should be 50 times 1, 50 times 1. Okay, so it should be 15 volt. 15 volt. Okay, so V should be Vx plus 10 volts. So 15 volt plus 10 volt, which is equals to 25 volt. 25 volt. Okay, 25 volt. Using this approach, we can determine the power absorbed by the circuit, the power supplied by the circuit, and in each section of the circuit, which element is absorbing power and which elements are supplying power. So we can differentiate, and also we can count down we can count the number of elements in the circuit, how many dependent sources are there, how many independent sources are there. If dependent sources are there in the circuit, what type of the dependent sources? Is that voltage source dependent sources or current source dependent source? If voltage source dependent sources are there, so what type of voltage source dependent sources are there? That means is that voltage control voltage source or current control voltage source? If there is a dependent current source, what type of current source are there? That means is that current control current source or current controlled, voltage controlled current source. So we need to identify, and based on this, we can determine the voltage at any element, the power at any element, or the values of the power for power supplied or power absorbed. So that's all for today. Please subscribe the YouTube channel, like, share, and so that it will be accessible for the others. Okay, thank you very much.